Hello everyone, today we see how to implementation of JK flip-flop using VHDL. Okay, so before we going to develop, we want to see the block diagram, circuit diagram and truth table. So this is the block diagram of the JK flip-flop. So input is the JK and controlled by using clock signal. And output is the Q and not Q. This is the circuit diagram and this is the truth table. J and K 0001 01 10 like that. If one that state that q1 q01 and next state and previous state output. Okay, so if both are 0 means then there will be no 0. 0101 means that is reset. If j is the 1 means that is set. If both 1 means then that is the toggle. Okay, by using this only we're going to develop the code. Okay, so to develop, just to go create new file. Okay, here just use JK flip flop. Okay, give next, and here we want to select the language, family and speed. After that we want to file. Okay, so here just give the VHDL model and give the file name JKF. Okay, JK flip flop like that. Next, here we want to give input and output. Okay, already developed the code for this one, so I want to okay. So if you check the code means, so this is the library functions and this is the file name and this is the input output and this is the signal going to use, and input is declared here. After that we are using if conditions and also the case statement. If using if condition means clear, if clear is 1 means then the next state will be 0, preset is 1 means then the next state will be 1. Then control by using clock signal is 1 means then depend on the JK input that state will be changes. Okay, so and after that the next state is the Q not, and not the next state will be Q not, and output and next state will be previous state. Okay, so let's save and we run the code. There is no any error, so we check the simulation part. Okay, for that just to go, if you want to use combinational circuit or means then you will be able to see the circuit diagram and all. Okay, so this is the circuit for the JK flip flop, and this is the technological diagram of the flip flop. Inside the LUTs we can able to see the AND gates, logic gates, and we want to check design summary. There are two types of circuit is there, combinational circuit and sequential circuit. So multiplier adder doesn't all the combinational circuit, flip flops memories that and all the sequential circuit. So we want to see how much area we used. So we used sound input output and inverters 2 and flip flop 1 and total, and we want to see the time delay. So delay is to 2.111 nanosecond. Okay, this and all the and 2.346 nanosecond. Okay, so like that, offset preset values for the delay. After that we want to see the power analysis. Okay, in place and route. So that place and to power distribution we want to see in place and route section in the implement design. After translate map and place and route, generating place and post placement, after completion of this process, then the X power analyzer window will be open. There you can able to see the static power of the designed one. Okay, so keep your processing speed -5, then only the processing speed will be in good. Like otherwise the processor speed will be very slow. So all translate map place and route and all run. Now we see this power, how much static power is. 0.060 is the total power for the this one. After this we want to check the simulation. So we want to create test bench, but for the tutorial I'm use the just in manual. I will give the input and output. Okay, so we want to set the clock signal for the to give the clock signal. Just go the first clock here, just give the leading edge 1, trailing edge 0, and the period 100 nanosecond. Okay, next JK input. So first content 0, okay, the preset will be 1, clear will be 0. So next 0 0, 0 1, 1 0, 1 1. Okay, and if you give preset 1 and clear 1 means, then you will can't get the put. So the data will be stored here, and we will see timing diagram of the, okay, this is the timing diagram. So JK and the pre-state and the clear will be control. Okay, if you see clear will be 1 or the clear will be 0, only we getting the output. If clear will be 1, is following the previous state. Okay, so thank you. Today we seen JK flip-flop and parameters of the JK flip-flop, and also simulation diagram of this JK flip-flop. Okay, thank you.